Hello everyone and welcome back at CodingBulls. Today we will continue our beginner's C++ tutorial video series and we'll talk more about classes and we'll look into overloading operators. Let's open our codebooks and we'll continue from where we left off in the previous lesson. So let's go ahead and go into our point classes. And let's say that we want to add 2 points. By adding them, will simply result in another point where the x and y coordinates are added together. So, if we have 2 points, point A and point B, then A plus B should be a new point with the x coordinate as the x coordinate of A plus the x coordinate of B, and the y coordinate should be the y coordinate of A plus the y coordinate of B. So we want to do something like this, and if you remember our constructors, we have a constructor here that if we have this in the constructor, then it will return a point like that. So in order to overload an operator, first, like in a regular function call, we need to define the return value. In this case, we will return a point, and then we will need to type operator because we are overloading an operator, and after that we can actually type the operator that we want to overload. In this case, we want to overload the plus operator, and then where you would normally have the parameters for the function, you will have one parameter here, but on the right side of this plus operator, which will be also a point. In lots of cases, we call it other. As you can see, I will also call it other here. So when we are in a class, it's good habit because the left side is this and the other side is other. So it's just a simple way to call it. And then inside here, you can implement the function and return the value. So we will just make a point, call it result, and it should be like constructor the same way as this, and then we can return this result. Now one more thing is that if you have a const point, so if you define a point somewhere, it should be a const, meaning that you can't change its value. But in the constructor you can assign a value. So let's say that you start it like this. So if you have a point like this, you won't be able to call this function here. The reason for this is because normally const with the const values, you can't call any functions because they have the possibility to change the value, which is not allowed. So in order to avoid this, if you want, you can add a const here, meaning that this won't change the value of our current point. Be careful though, because if you type const here, now every attempt to change the value inside of the function will result in an error. So you can add this, and you should add this if it doesn't change your point or your class, that specific member. But if it changes, then you shouldn't add it because it will result in an error. So now we can use const points as well to add them together. So inside here, the parameter, you also want to make sure to have a reference, because otherwise, if you just type this normally, the compiler over here go ahead and make another copy of this class. And then after that you can change that value, but it won't affect the original value. A reference is something that now we don't make a copy, we will just pass it by reference, meaning that we have the reference to the point other, and now we can actually, if we change the value of other inside the function, then we will change the original value as well. You can use this reference trick in other functions as well. If you want to make sure to change the value, then you should pass by reference. If you have a large object, then you can pass the reference to avoid making another copy. But if you want to make sure that you can't change the value of that inside of this function, then you need to type const. This is because if we add two points together, we expect those numbers to not change. So just type const here and then a reference. That way, it won't make another copy of this, so it will be faster, but it will also make sure that you can't change the value of it. So now our overloading operator is complete. And now, if we make 2 points, even a const point, to add 1, and then we will say it's 2, 3, and then let's say the other way is not a const. It also works if they are not const. You can have const and you can have not const, and we will have, let's just say 4, 5, and now we will have a new point. That's when we add together these, and then instead of a constructor, we let it have a default, but we will also assign the value of the added points. So to add 1, and now we can use this plus operator because we just overloaded it, and to add 2, and then let's go ahead and output hit point, and then now we haven't overloaded this output operator yet, so for now we will say that edit point dot x, and then with a space edit point dot y. After that we will go ahead and overload this operator as well. So now we will go ahead and run it. We got an error. Yeah. So I copied from here where I said that the intro's names are A and B, and then I forgot that the names shouldn't be like this here. So you have this, which is the point on the left side, and the other is on the right side. So you will have other, and then you will have this, and you will have other. So let's go ahead and do it again. And we need the getX function and the getY function because these x and y variables were private, and therefore we can only access them with these with these functions. So if we go ahead and run it, and we can see that the added point is 6, 8, which is correct. So that's how you overload an operator, and now we can go ahead and overload other operators too. So let's say that the value subtract 2 points PRB to subtract the x and y coordinate. And you can do anything else inside here with your functions as well. So let's say that multiplying it means to multiply x and y. And you can make any other logic behind this. So let's say that we now want to make the plus equal operator. So we want to modify the first number just like the integers. So we can say that, let's say that to add 1 should be plus equal to add 2. So we want to make sure that this works as well. So we will have this void operator plus equal, then we will have const point as well. But in this case, the function itself won't be const anymore. So the first value on the left side shouldn't be const. On the right side, it has to be const because you don't change the right side, but you change the left side. So what you will do is that this dot x should be plus equal to other x. And same with y. And that's the plus equal operator, and we can also make these operators of minus equal and times equal. You just change these values. Now let's make division operator as well. And this will be a bit more complicated because we can't divide with 0. So doing this could result in an error if the other dot x or other dot y is 0. So we will go ahead and take a look on that case. So we will have an if and else back. And we will also have so if other dot x is 0 or other dot y is 0, then we can do this. If it's not, then we can just divide regularly, and if it's 0, then we need to come up with something. We can either return an error message, or we can come up with our own way to divide points by 0. So let's say that in our case we want this point to be on the infinite position. So we actually implement another logic based on that. So we will take the two options. If this one is 0 and otherwise we will different value and here as well. So if other dot x is 0, then we will have this value new x and new y. So if it's 0, then new x will be int max. We'll put it in the infinite. And here new y, new x should be simply this dot x divided other dot x. So we can divide here. And remember that this division will take the lower bound of the division. So it will put the value down if it's not a whole value. If you want, you can change the point for long tuples as well if you want to have any number that's not an integer. In our case, we will just stick to the points which have integer coordinates in the coordinate system. So we will return an integer always. So here we will repeat the same process. Your y should be int maximum here. Otherwise, it should be this dot y divided by other dot y, and then we will have a result point, which will be in this case new x and new y, and then we can return the result. So if we take a look in this function, there are lots of if and else statements, and this can actually be more easy to see if we remove some parts. So the way we can do it is that you can see that we will have a point result, and then we will return a point result here and here as well. So we can delete this else part and this if part, this outer if part, and actually have already the new x and new y value, and we will return based on that. So if x and y, dot x and dot y are not 0, then we will just run into these else statements. So the new x and new y values will be with our division. So we don't need the test part, and we can just return like this normal and we got rid of one if and one else statement, making our function easier to read. Now we will have the same stuff about the divided equal. So we will just copy this function and it will be this similar. So here, instead of returning a result, we will update the this.x value and the this.y value, like this. So now we have all of our operators that we wanted, and now we can go ahead and try them. Let's try our division, and you can go ahead and the same way as you can see here, add more points and try out the other operators as well. I just want to show your division. Let's say that we will have a 0.52, and we will have a point which will be actually 0 here, and let's say 3 here. So 5 divided by 3 based on an integer division will be 1, because we take the root of 1, and 2 divided by 0 in our point system will be infinite, the integer max, which is an actual integer number, so not an infinite value, but we will refer to it as an infinite point. So we will say that, let's say that we will use the division operator, divided equal operator like this. Then we will output this to the 1 value like this. So now if we go ahead and run it, we can see it will be 1, and this number is the integer maximum. So this is how this division will work for us, and you can go and try for the subtraction and multiplication. So another operator that we want to overload is the output operator, because as you can see, it's really not comfortable to write all these codes to just output a point, and here as well, every time we need to write it, so we want to avoid this. So we will go here and overload the output operator. This will be a bit tricky, because instead of just simply overloading like this, we will need to have following line. So we will say that the output stream should be the operator of this output operator should be a friend of this class. A friend class means that it can access private variables from this class. So normally you can't access these private variables, but a friend class can. So we will have this operator, and we will have OStream operator is, by the way, any output operator, so it works for the files and it works for the cout as well. If you remember our video about how to output to a file system with OStream, then you can use it the same way. So I will call this out, and then make sure to have the point as const reference. You can, by the way, put the reference here or put the reference here before the name as well. So after the type or before the name, it doesn't matter. I put this here and got point. And then this will tell that this type of output operator will be the friend of this class and can access these private variables. And then outside of this class, we will define this function, this operator function. I will overload this. So what we will do is that we will, this is our output stream right now. So instead of cout, we just write out. So it can be the cout as well if we pass the cout here, or it can be another file as well. So we will output the point.x, then we will, let's say that we put a space, the same way that we did, and then output point.y. And then, if you see, we need to return something, an output operator, and we will return out. The reason for this is, if you see, that we can output multiple things in one line. And that is because this operator always returns itself, so we can further refer to it. So if we have some line where we have cout, let's say 5, and then apple, so, and then certain or anything. So first we will have this cout 5, but in order to further refer to it like this, this will return cout. So it will make the output, outputs the 5, and then it returns the cout, the construct, or in the case of files, the offstream itself that we have. And now we will execute this part, cout apple, it outputs the apple, and now it will return cout. Now we will output certain. So in order to be able to use the point cout as like cout point, that it's a point, and then a space, and then apple, or anything like that, where apple is any variable, then a string. So in order for it to work the same way, we need this to return this cout offstream, or the file stream in that case, so it will return itself. So we can return cout here and continue. So we will output point.x and point.y, and then we will return that. So now we can go here, and instead of all of these, we can just output like this. Which makes our code so much easier to read and write. So now if we go and run it, and we can see that we have all the outputs correctly again, just with much less code and with only a small function like this. So this is how operator overloading and the friend classes work. Another thing is that if you want to refer to these operators inside of a function in the class itself, so let's say that you will have a point function here or something. So remember the way you can call this as point dot do something. So here the way you can call these operators is for itself. So this operator, let's say plus, and then let's say that you will have a point p with 1 and 2. Doesn't matter, I just want to show you the example, and then you will pass this. So now you have this point 2, which will be this point 1 plus this point plus this other point. So the reason I showed you this is because it's slightly different, so you can just put plus. So you need to actually this and then refer to this operator like this. Because if you just type this plus p, which would be the usual way to say that it's this plus p, it seems really logical because we refer to it as this, as I told you, but it's actually not correct. You need to explicitly tell it that it's the operator plus. So if you want to refer to this in an operator, you need to do this. Alright, maybe go ahead and delete this because we don't need this. And one more thing that I would like to talk about in today's video is the templates. So a class or a function can have a template, which will mean that you will have another class here, and usually we call it capital T, or you can call it anything, and this will be a template class, meaning that your point, when you define a point, will need another class into the declaration. So if you remember the vector, when we type this vector and it, or any other type here, so this is a template. The std vector itself is a template class that you need to provide the type of variable that it will store, and it can be any type of class. So here we have a class T, and now we have vectors of integers here. So if you want to make a point now, you need to make a point and then provide a class here. So like point integers or point long doubles. So the reason for this is you might want to use the integer type of point, and sometimes you might want to use the long double type of point. You can have a bunch of different types of points. So let's say that we will have this class. So this will refer to the type of x and y. So it will contain different types of points. You might have long double as a point or an integer as a point, anything that you can use here. So now instead of integer, we refer to this as capital T. And here inside, we will also expect something that matches this template class. So here you will remove these integers as a T, and also here you will remove it. And then here now you can no longer refer to the point like this simply. So you will return a point of the same type of this capital T. And it's really important that any type that you provide has to have these operators here, because we use the plus operator. So it's not a problem for us now, because you can add all these type of numeric values together. But if we would try to use the point, and inside of the template class we will provide vectors of doubles on any other type, you can technically do that, but not in this case, because we will use these operators which are not defined for the vector class. You can't multiply two vectors. I mean, you can come up with a way to multiply two vectors and overload that operator as well, the same way that we have here, or for any other class. But for any class that you use here, it needs to have these operators to use this logic. So, and here as well, instead of integer, you will have a T value. And now it's interesting if you still want to keep that int maximum or have a different value, because if we go ahead and build it, we need to have the template class here as well. And now, because we have this T, then this function needs to have a template as well. And class T. So here as well, we need to have this template class. You can have like an integer fixed in this triangle, or you can have a template class for the triangle as well. And then of course for the color triangle as well, and then you will inherit the same class from this t type. And then here you will have these points with the same type. Inside here as well, you will have this. So a very good trick if you want to go ahead and fix everything in your code is just press period, and it will put you next to the next error. So you can just go ahead and take a look, and then you can see that what issue we have here, and you will get this bunch of weird errors. So this one, triangle, it doesn't have any built-in triangle. So here you will also need this template class, and here as well. So it's much faster than if you keep reading code. You can just go ahead and see. And now we got to the main function. And now here, from now on, every time you make a point, you need to provide what type of points you will have. So these will be integer points. And let's say that our division point will be long tuple now. In this triangle, let's say that it will remain, or let's say that it's a long type of integer, and the color triangle as well. It won't change anything here, but I really want to show you that we can have these other types. And this will be integer again, this will be integer, and this will be integer. Or you can also type auto here, because from the return value of these two variables, it will know that it has to be a point of integer types. As you can see, here it will complain that for these parameters we don't have a constructor, because this expects the same type of parameters as, so this class has to be the same. So here we will actually need to use the same type as this point. So we will have an integer, and let's say that this will be the long sum, long points, and the long endpoints. And same for the color triangle, it needs to be an integer. So now if we were to change this as a point, long, that's the same, because that's the value. But if we change it to, let's say, a long point long tuple, and if we build this, it won't be able to convert from this type of point to that type of point. So we will keep it long, or we will keep it out, whichever is more comfortable for you. And we will test this long tuple. Another important thing is that here we assign the int maximum value to the new x in case of if it's 0. So we expect this to be a numeric value that you can assign. If you try to do a point of, let's say, vectors of integers or any like other type of stuff, and you didn't just build it, then you will get a complaint from here up here that, hey, I can't assign a value 0 to the class called vectors of integers. It's just not a thing, and in lots of places. So you can't use it like that. You need something that you can assign these values to. and here we will have again a template class T. So we need to call it a different template because we already have the template T running inside of this point class. So we will just call it K. I will call it K here as well. So you can see. So now we are finding template order errors, and it's also important that the template class here needs to be able to output this point x and point y. So you can only use it with values that you have this output operator assigned to. So now if we go create and run it, then you can see we have all these values the same, and now the divided point will act like a long double type of points. So this is the same type of number. This e plus 009 means that 10 to the power of 9 times this number. So it's the same as that previous number that you saw. See, but this is the way it outputs in case of long numbers. Or if you remember our previous video, you can actually set the precision to another number. So let's say that we want to precision to be 10. If we break and run it again, it will be able to output it correctly. So you can just set the precision. Hopefully you enjoyed today's video and you learned more about overloading operators and templates. If you did, make sure to like and subscribe, and see you in the next video.